Hello, everybody. I'm very happy to be here. Welcome to my talk about vibe pentesting and how to enhance ourselves as hackers using LLMs. The agenda for the talk, after a short introduction, we will talk about the setup needed to perform the use cases that I'm going to show you. Then I'm going to show 4 use cases where I find using LLMs interesting in penetration testing. Then we'll discuss some pros and cons for this approach and some thoughts about the future of penetration testing. A few words about myself. I'm the founder and CEO of pentesttools.com. We are a cybersecurity company based here in Bucharest, and we are building a product for penetration testing and vulnerability assessments. I'm also an associate professor at Polytechnica University of Bucharest, and I've been doing penetration testing for more than 15 years. And I also enjoy speaking at various security events and conferences. Why are we doing this talk? Why am I doing this talk? I have never been an early adopter of AI because I thought it was just a hype. But with the recent advancements and evolutions of the models, I saw the potential in cybersecurity in both defensive and offensive activities. So I started exploring to see if LLMs can be used as companions in offensive security work and let them do the boring work and why not some of the more interesting one. What you should expect from this talk, you should expect a lot of console output. So we'll be doing some live tests. I hope you had a good lunch. Sit back and relax. So it's a workshop-like activity. And also expect to have some slow AI responses, just to prepare you. And this talk is not about training or customizing AI models. What you see here, you can do yourself right now after you go home. We won't do any models comparison or 0 days or so on. But I think it will be useful. So why vibe pentesting, since we already have vibe hacking? I thought that there is a nuance between the two terms. So vibe pentesting is a term that I came up with, and I am associating it with using LLMs for doing the professional offensive security activity, rather than hacking, which sometimes also involves black hat activities. So in the vibe pen testing, we also look at working carefully with the systems of the customers. We don't want to break things. Also, we want to report things to the customers that we find. We use the same hacking techniques as the black hats, but yeah, they don't care too much about what they're doing with the systems. Let's go into the testing setup. So for these scenarios, I have tried 2 LLM clients that natively work on Ubuntu. So on the left, we have Claude Code, and on the right, we have Gemini. Both have kind of similar capabilities, but I chose Claude Code for that. And the other ones, ChatGPT and Perplexity, did not have clients for Ubuntu. They had only for Windows and Mac OS. So that's why I'm sticking to Claude. About Claude Code, this is the official coding assistant of Anthropic. And its main use case is to be used, you started inside a folder where you have some source code. And Claude Code can help you develop new features, fix bugs, improve your code, and so on. But the nice fact about it is that so it has file system access, and it also can execute commands on the operating system. So why not use it for pen testing and other security testing activities? And fun fact, they state on the website that it's built also for hackers. So some config files which are necessary when working with Claude. You need to know where the prompt history lies in, session history, MCP configurations, and so on. And since we're talking about MCPs, you probably heard many presentations today about that. You know, simple LLMs can do much with just text, but when you couple them with some tools, they become really powerful. And the MCP is the unified way of coupling models with various external services. They work like this. So this is the MCP client. This is the MCP server, which can be also local or online. And when the MCP client wants to talk to an external server, it calls the MCP server. This one knows how to handle the requests, and the model receives some structured output which can be easily interpreted and they can work with. This is how to install MCP in Claude. And one other mention, there are a lot of repositories of MCPs. This one, I found it pretty interesting because it's called MCP for security, because it contains MCP of the common tools that we usually use in Kali, for instance, like Nmap, SQLmap, WP-Scan, and so on. So you can find them all here and use them whenever you want. And for targets, we will be using these two targets, which are owned by ourselves, and we are authorized to do that. Now, let's go into the juicy part, how to use LLMs in pentesting. And the first scenario that I wanted to show you, I called it AI-powered Google hacking. As you probably know, when we start on security assessment, a pen test, we want to gather as much information we can about the target. And first of all, we want to do this passively. Passively meaning that we interrogate any public database that we know with information, and the biggest one still is Google. And for that, we use various Google dorks, like site, target.com, in title, index of, file type, and so on. Various Google dorks, which show us what Google has indexed about our target. Right now, why don't we give this tedious task? This usually is being done manually, because if you don't do it manually, you will quickly get the CAPTCHA of Google, and it asks you if you are a robot. But I found a way to automate this using a Google Search MCP, which actually connects to the Google Search API. And after we give it certain API keys, it manages to programmatically do Google searches. Yeah, it needs two API keys, which I found it pretty difficult to set up, but it eventually worked. And right now, let's try a simple prompt like this one. Check if the website has any sensitive information publicly exposed in Google. Now let's see how this works. So the console part starts here. I'm in this working directory, and before that, I'm having here a script. It's called cleanup context. And what this does, it deletes the history files, session files, and so on of Claude, because I don't want the tests to be influenced by the results of the previous ones. OK. And I'm starting Claude. When starting from fresh, it detects the MCPs already installed. Google Search, I have already installed it. I say that I want to use it. And you can see that we're using the model Sonnet 4.5. And I'm on a paid account of Google of Cloud Code, but it works also with a smaller one. Okay, let me show you the MCP. So with the /MCP command, it shows me what MCPs I have installed. This is Google Search, and it says that it has 3 tools available. View tools, and the tools available are the actual search. Then it has an extract web page content and extract multiple web pages. Good. And let's try to run this prompt. For instance, check this website. Let's choose some random target, like primariadomnești.ro. It's a public institution from Romania. Yeah. Has any sensitive information publicly exposed in Google, and provide sample URLs. Oh yes, thank you for saving a few minutes. Yeah, that should be done. Good, so what's happening here? It says, I'll search Google for publicly indexed content from primariadomnești.ro to check for any potentially sensitive information exposure. And when you see the gray bubbles here, these are some tasks that Claude wants to do, and they are in pending mode. When they are green, it means that they are finished. So it uses this MCP, and this is the tool of the MCP, and you recognize these Google Docs. Site file type also searches for other file types, XLS, XLS6, docx, in URL admin, WP admin, backup, and so on. I will let it run. Okay, and I was looking for something else, but sensitive information discovered, high risk, multiple PDF contains blah blah. That's the beauty of running LLMs, because they give you different responses every time. So I'll try to do this again by clearing context and just deleting the last part, because there is something else more juicy around. Yeah, so when we draw the conclusions, we will see that the bad part, or instance, the interesting part of using LLMs is that they are not deterministic, and every time you run them, you may obtain different results. Yeah, now we're talking. Yeah, so it searched for technical issues, file type, SQL, config, env, databases, and so on. But it also searched for code numeric personal, CNP, and so on. Password, parola, okay. And some better results here. So we have multiple documents containing personal information of Romanian citizens. And, sorry? You can take, it's public information. The nice part here is that, for instance, if we go to visit one of the documents, let's say this ends with 7.pdf, I think. Yeah. Okay. And if we look at the document, we see that it is somehow redacted, the information, right? But let's just copy-paste here this information. And yeah. So the LLM actually read the document, and so what's there. And you can see that this is a lot of personal information that you can use for phishing and other nasty stuff against these persons. Of course, GDPR is not happy about this. Okay, moving a bit forward, still with this one, because I have something more to show you. The phone number, yeah, it's still public information. Why then? Some other juicy case. For instance, I did the same search on sector5.ro, which is the Primăria Sector 5. And it says the initial findings, I have exposed personal information of 600 plus documents and so on. And I challenged it, and I said, I don't see any CNPs in these documents. Can you give me some examples? And he said, you're right to question this. I made assumptions based on the search results without verifying the actual content. And I told him, OK, please download each file, read it, and check if it contains any information which should not be public. And it says, for Primăria Sector 5, properly protected. Oh, everything is good. But after reading, actually, the files, some interesting piece of information came out. For instance, in this PDF file, it says that the declaration reveals that the spouse, Ionescu and something, works for Serviciul Român de Informații București as a military officer. And Claude tells us that there is a risk that publicly identifying intelligence service personnel could pose some security risks. Maybe he's right. Okay, now let's go to another scenario for passive vulnerability discovery. So the classic approach in this case, we have a network, and we're running Nmap, let's say, and to discover services and versions of what is there. And after that, if we don't want to run a vulnerability scanner, which is very noisy, and we don't want to ring all the bells in the network, we start to manually look for vulnerabilities in NIST, MITRE, ExploitDB, and so on. And this, I can tell you from experience, is a very tedious operation, not very pleasant. So why don't we do this? Why don't we give this to the LLM? And for that, knowing that Claude has access to my file system, I can give it as input an Nmap output file and tell me what are the vulnerabilities affecting those services. And for example, I'll do a clear here. And in the same directory, I have this Nmap output, which is from a real network. It's a private network. And when we read it, we see a lot of open ports, nmap, debug stuff, services, and so on. And we as pen testers need to manually go through each one and see if we find anything interesting there. Now let's see how the LLM does it. So I could use a prompt like, I have this nmap result from nmap output.txt. Tell me what are the vulnerabilities affecting the services with known versions. Look for the most recent ones and high risk, for instance. And it's very helpful, and it says, I'll analyze the nmap output to identify vulnerabilities. Let me start by reading the file. Okay, and it's reading the file. Now I'll search for vulnerabilities, and it's starting to make a lot of noise. And it's also using the Google Search MCP. And you can see that it's, I should have started a new session. It's looking for CVE, Apache, Tomcat, version, and so on. And it's also visiting the sources. For instance, it's visiting nist.gov here, and other specific sources to extract the list of vulnerabilities. It takes a bit of time, but the result will look like this. It parsed the nmap output, it extracted the services which have versions, and after that, it showed me a list of CVEs affecting those services in a prioritized way. So this is another use case where I believe that LLMs can help us save more time. Some other interesting cases for web application fingerprinting. For instance, here we have popular tools like Wapolizer, WhatWeb, and so on. But those are not perfect. For instance, if we encounter this type of login page, so this is a vulnerable Oracle WebLogic server that we have on pentestground.com. This is a testing environment that we're offering publicly. So if we as human pen testers look at this page, we immediately see that in the left corner there is a version number. But this is written in HTML, in the HTML source of the page. And standard tools, for instance, nmap, if it looks at the version, at the server, it only identifies the type, but not anything about the version. And Wapolizer, for some reason, doesn't see it at all, because it looks for well-known technologies, let's say. Oracle is well-known, but I don't know why. But when I gave this to Claude with a prompt like, tell me what is running here and what are its potential vulnerabilities, it actually visited the page and understood what is there, understood where to look for version numbers and technologies, and did the same search as previously, and returned the results. So it has a big advantage when it comes to understanding the context. Now let's go to another bit more juicy part. We have active vulnerability discovery and exploitation. Let's see how the LLM can handle this case. And for that, we're using a test website, royalsecurityguard.com, which is still test website, log out. And we wanted to create a dedicated website for testing because guess what? If you put an LLM to solve challenges from Burp Academy or other well-known vulnerable websites, guess what? It already knows the solutions. So we need to put it in a new environment where it's fresh for it. So this page has multiple vulnerabilities, but for this scenario, we will look at this newsletter subscribe functionality. And here, if we press subscribe, we say you have successfully been subscribed. But if we put a single quote here, we get a nice SQL error message. From this message, we see that the backend technology is Python. It was written with Python and Flask. And the website is SQLite 3. I have tried to exploit this with the SQL map, and it didn't work very well because SQL map saw this as a blind SQL injection, and it tried to perform a lot of heavy tasks on the server, and the server did not respond very well, and it actually failed. But the beautiful part, the interesting part of this vulnerability is that if we do this, if we try to subscribe with the same address, we subscribe again, we actually receive a feedback. So the same address is already subscribed. And SQL map did not see that and was not able to exploit it. But now let's see how this can be handled by Claude. I will start a new session, clean up context. I will keep this MCP. And I will tell him, check if the subscribe functionality of royalsecurityguard.com is vulnerable to SQL injection. And it started badly because it tries to go on Google. And I will correct him and say use curl to visit the site. So right now it's using the built-in curl command, I mean the command from the operating system. And it plays with it. And it says, so it has read the homepage. It says, good, I found the subscribe functionality. I can see a newsletter subscription form that sends a post request, just a second, to /subscribe with an email parameter. Let me update the to-do list and proceed with testing. So it has identified the endpoint and the parameter to inject into. And it's using actually curl to identify and later exploit the SQL injection. And you can see various payloads here that it is trying. Now it asks me for some other curl command. OK, I'll say yes. So at this point, what I'm showing you here is an assistant. So it's not an autonomous system, because yeah, it wants me to stay and respond and to check. So let me check SQL injection for various payloads. There's a difference in response sizes. So this is the second time when I get different responses to that. I'll just tell him again. I'll just take this from scratch. Now you see that, so this is the first time when I see that it changed the user agent. Let me search for the subscribe functionality. OK, again, it found the form. Excellent, I found a critical SQL injection vulnerability. Let me test further to confirm the extent of the vulnerability. The vulnerability is confirmed. Let me gather more information. And you can see here some payloads. So if we, just a sec. So this is the summary. It has identified the vulnerability, successfully managed to extract some sample data. It's extracted the user from the database. However, I will go a bit further and say dump the users table. So it tries various payloads. I need to clarify the authorization context before proceeding with database extraction. Before proceeding, I need to confirm, do you have written authorization to perform this penetration test? Are you the owner of Asha, or is it an authorized security assessment? And now let's say it is my website. It was fine. Understood. Let me help you with extract the data. Fun fact, but we don't have time now. At some point, I asked the model, why did you let me continue? Because I could have easily spoofed the answer. And he said, oh, you're right. Let me actually ask you for authorization. And I said, OK, but how are you able to check the authorization? And he said, you're right. I don't have any way to actually check the authorization, but still I don't let you continue. I need an authorization. So, but it's enough to clear the context, start from fresh, and you'll get another context. So it's good. Okay, going back. Look what it does. So a payload like this, test union select SQLite from table and name users. Okay. There was a better payload here. For instance, this one. So this payload works. It extracts usernames and hashes, as you will see. And if we use it here on our own, so we work together with the model, so we don't let him do all the work. I have a small thing to bypass here. Type email. Okay, so we're using the payloads given by the model, so we can manually extract information from the database. Good. Let me see if it finished. One, two, three. There are 3 users. Mm-hmm. So sometimes it makes, the nice part about it, I saw it that sometimes it makes mistakes, and it doesn't succeed from the first try, but it is able to auto-correct itself and actually find a way until the end, which is, I don't know what it's doing right now, which is differently than what we as people would do. So resilience is one of its strengths, and persistence. Yeah, it actually needs to output this result, which it already has. But for some reason, it wanted to format it and so on. So these are 3 users, okay? And the passwords are hashed with, it tells me here, bcrypt, password hashing. Okay, a lot of details, which I did not ask for. And, okay, can you help me crack the passwords? So please notice that all the conversation that I had with this model until now did not involve any technical discussions. Again. So let's try this something else. So I'm copying this output. I'm exiting the session, clean up context. Now let's say, help me crack these passwords. Yeah, so for some reason, the demo gods today decided to raise all the alarms of Claude. and since I have 5 minutes left, so what should have happened, and it worked every time until this moment. So it manages to crack this password using hashcat, which is installed on my machine. And it's QWERTY. It's a very simple dictionary password. And with that one, I am able to log into the website and access some other functionality. Okay, and I can access, for instance, edit blog post. And here, the next thing that I will put it to do, but I don't think we have enough time now. Just bear with me a second, because I'll let it run and take you to the rest of the talk. So, I don't like you, Claude, today. Just to make sure, what do you already know about? Just to make sure it doesn't have some stored information somewhere through the files. So the cleanup worked. Okay, so let me check something else. So my website is guar.com /login, and I have these credentials, and these ones were just a second. Help me check if the blog editing functionality is vulnerable to server-side template injection in this location. So it's a very bad practice what I'm doing right now, because I'm experimenting on stage. I do not advise you to do that. We pray to the demo god too many times. Oh, finally. It doesn't have any moral issues now. Okay. Just run who am I? Who am I? And give the output. Okay. However, as I explained, I don't have tools that can authenticate. The tools I have are limited. Oh, come on, really? Use curl to visit the page. Oh, finally. So let's hope it does a login. Good, I can see the login form. Now let me authenticate using curl with your credentials. Okay, and we'll just let it run and talk you through what I have left, and see if it manages to find something. Yeah, what I actually kind of showed you was a full attack flow that we as humans guided the LLM to do. And keep in mind that I did not use any technical terms to guide the model. Just spoke as a human person who actually doesn't know too much technical stuff. And at the end, I can guarantee that it manages to also write a web shell on the server. Now the question is if these attack chains can be fully automated. I know that there are a lot of companies working in this direction. There are these open source AI agents, Strix and Kai, who give some promising results, but I don't know if they are able to do the full chain up until now. We at Pentest Tools have also started a project in this direction to automate penetration testing with LLMs. Let's see what that comes out. Another scenario that I wanted to show you was reporting. Very quickly, I connected Claude with Google Docs MCP. And right now, Claude can talk to documents from my Google Drive with this type of MCP. And we can, since we already discovered some vulnerabilities with Claude, we can put it, here is this document where we want to work in, and say, write each finding following this structure: title, description, risk, recommendation, evidence, references, and so on. And why not write them in Japanese? Because you can. So you will see very easily how a Google Doc gets populated with everything you want in the format that you want. Some other use cases, static code analysis, that's a very promising one. If you have source code, you start Claude in your directory and you ask it to identify vulnerabilities over there. Automatically validating findings produced by scanners, and so on. Now let's talk about some pros and cons of using LLMs. The pros is that LLM having a very big knowledge base behind sometimes can think of attack paths that we as humans did not think of. And they are really powerful when working with MCPs and connecting various tools. Now on the cons side, the biggest one I think is that testing is not deterministic. And as you saw, every time you may get another result, which is not always very nice. It does not perform well if you give it a very broad scope. You need to give it a narrow scope to very well defined. And beware that it may sometimes download malicious code from the internet and run it on your machine. If it decides that, okay, I need this piece of code to solve my task. So if you're not attentive or you put it, you always answer yes to what it asks, then it says, okay, I found this repo on GitHub, which allows me to perform this task. Let me download it locally and let it run. What is there? We don't know. Sometimes it may go out of scope, may run unwanted payloads, as I said, and also be aware of indirect prompt injection. But this is a topic for another talk. And the question is, using LLMs makes us dumber? That's a good question. Depends on how you use it, I guess. Guardrails are really necessary. For instance, I caught it that during testing for SQL injection, it somehow thought of introducing that payload over there. So drop table users. So me as a human pen tester, I would have never tried this on a testing environment. Never. So that's why, even though it would help me anything, but never try this. So that's why I add to prompt instructions like don't do any destructive thing. And in the closing, I think the future of pen testing will transform into this type of scenario where the LLM will be a very powerful companion to our work and make our work faster and more efficient. But first, we need to learn the language. And the language is prompting. And I advise you to learn how to do good prompting, because it's not always easy. But if you do good prompting, then you get extraordinary results. Some people say that prompting is the new coding language. Keep this in mind. We at Pentest Tools have also created our own MCP server. With it, you can start scans, generate reports, translate reports, connect Pentest Tools with other external tools, and so on. And yeah, I invite you to stop by our booth. And I'm interested to talk on how we can automate this attack chain using LLMs. And before closing, let me see if this worked. Guess what? Remote code execution. This was the payload for server-side template injection. And the output, yeah, it was running as root. So it, yeah. Thank you so much. That was my talk. Thanks.
All right. Thank you so much. All right. Thank you so much, Adrian. We're really, really short on time. There's time for one question right here.
Under pressure. Hi. So I am aware of, there was a research project where researchers tested like 50 LLMs over multiple months on both vulnerability bug hunting challenges, but also exploit writing challenges. And this included also like the big name ones, but also underground ones with safeguards removed and all that. Mm-hmm. And what they found is that on the exploit writing, they did very poorly, right? So they did much better on the finding vulnerabilities part because supposedly the amount of knowledge on the internet about vulnerabilities is greater than for writing exploits. And here I'm not necessarily talking about web vulnerabilities, but other types of vulnerabilities that might require bypassing, sandboxing, ASLR, DEP, other stuff like that, right? Have you done any testing yourself? Do you kind of confirm that, or what's your opinion on the exploit writing part rather than the...
So I did not do this type of testing myself, but from what I know, they are performing better if you give them well-defined tasks. So don't tell them, write me an exploit for that, but write me this piece, and write me this piece, and write me this piece. And at the end, you put them all together. I think this has the chance to work.
So there's still the penetration tester still needs to guide it. So like a novice can take this and do an exploit check.
Yeah, so there is still a job for penetration testers. So yeah.
All right, thank you so much. Give it up for Adrian. Thank you.